In week 4, we're going to talk about vent design and installation requirements for Category 1 appliances. This is going to be Chapter 3 in Unit 22 in your venting practices textbook. You will need to have your codebook B149.1 natural gas and propane installation code, and in the code book you're going to work on in Annex C, which is dedicated for vent sizing. We're going to see that in this annex we have clauses, tables, and figures. It is important for you to know whether what I'm talking about, for example, C.2, is it a clause or is it a table number or is it a figure number? So please pay close attention to that little detail over there. As you can see, Annex C is about vent sizing tables for Category 1 natural gas and propane appliances. And this is where we're going to do our work when we're doing vent sizing. So let's start with a few definitions, with a few terminology that is going to help us throughout vent sizing in this course. This is a typical representation of a single appliance. So what you need to start paying attention to is the appliance itself. And we know it is a Category 1 appliance. We've said that many times. You have either a natural draft appliance, which will be referred to as capital letters NAT, or you're going to have a fan assisted appliance, which will be referred to as capital letters FAN. There is no third option. These are the two types that you have. The next thing you're going to pay attention to is whether this appliance has a draft hood or not. As you see, this one is a draft hood equipped appliance. It has a draft hood, so you know for a fact that you're going to consider this when you're sizing the vent and looking into the tables. You're going to make sure that you look in the right place in the table, which is the draft hood equipped appliance column. The other thing is we have our connectors. The connectors can be single wall or can be double wall. However, our main vent must be a double wall type B vent. In Annex C, there are only two types of common vents or main vents. It's going to be either type B, or it's going to be, I would say, tile-lined masonry chimney. Okay, chimney. So that there again, there is no third option. It's either type B or a chimney. Shortly, we call it a chimney instead of a tile-lined masonry chimney. And of course, you have your rain cap that is indicating the termination of the venting system in the atmosphere. All right. And again, small details, they are very important. The dotted line indicates a type B double wall vent material. Okay, so these dotted lines here on the inside indicate the inside wall basically, and they're telling you that this is a type B. On the other hand, you have a not dotted line indicating type C or a single wall vent connector. And I said before that the vent connector itself can be single wall or double wall. Vent connectors can be single wall or double wall, type C or type B. However, the main vent must be, or the common vent must be, type B, or a chimney as we discussed, which is type A, by the way. Chimneys are type A, but they cannot be type C. And the reason for that is the code book in 8.18.23 states that a single wall vent connector shall not pass through either a floor or a ceiling. Okay, so this is directly from B 149.1. And if a venting material is not allowed to pass through a floor or a ceiling, how is it going to end up in the atmosphere? It's not possible to use this material as a main vent for this reason. And another thing is, let's emphasize, okay, let's repeat and emphasize that you're looking for a draft hood to make sure that it is either a draft hood equipped appliance, or it is an assisted fan assisted appliance. And then you are also never going to refer to this red section as anything but a vent connector. Okay, so you cannot call it a vent because that will be very confusing in the technical terminology. The yellow section there can be called a common vent if there is more than one appliance, or a main vent, or simply vent. Usually vent means venting system as a whole. Usually vent means that. All right, so let's have a look at our first example. Our first example, that is of a more than one appliance that we have here. As I said, the first thing is you're looking at the appliance. Okay, I have the appliance and nicely labeled. I don't even need to look for the vent connector, or sorry, the draft hood here, because it says right here, it says this is a draft hood equipped appliance, and this is a fan assisted appliance. So no ambiguity, it's straightforward. I know for sure what they are. And then we also find that we're going to call this a common vertical vent, or a common vent, because it is combining the vent gas streams together. And I would like you to pay attention to that square where vent gas streams are combined. Okay, so stream is coming from here, and another stream is coming from here, and these are obviously called vent connectors. In this one, they are type B vent as opposed to type C vent. All right, so let's also mention a few other definitions. Pay attention how the starting point of this vent connector is W, and the end point of it is X right here, where it's entering the common vent. Also, pay attention to that there is a linear length here, and that length has two components: the vertical component of that length, and then the horizontal component of that length. I should have gone all the way to the center here, there. Okay, so center line to center line, and this is the starting point of the vent. So the vertical component we always refer to as rise, not height. Okay, not height, as rise. And the horizontal one is adequately referred to as lateral. Okay, so rise and lateral are referred to, and they are the two components of the length of a vent connector. It is very important here to emphasize that height, when we say height, we mean the stack height, or the common vent height or the chimney height, never the connector vertical distance. Connector vertical distance is always going to be called a rise. Okay, both of them measured or the three of them, height, lateral, and rise, all three of them are measured in feet. And as you can see, the starting point of this second one is Z here, and the end point is X right there. So this is going to also give us a length of a vent connector, which also in its turn has the the two components, the lateral component and the vertical component that is going to be called a rise. Very important. Right, so let's jump next to our vent connector manifold idea. A vent connector manifold in real life looks like this. This is a common vent. This is a common vent, and it is type B, as you can see. First of all, let's type the type B. It's common vent, but it's also very importantly horizontal. Okay, so as you can see, this in the red section here, this is your common vent, and what we have seen in the image is just this part. We didn't see the part that goes vertically to the atmosphere. It's beyond this wall here. So this is your type B manifold, and what distinguishes a manifold from other arrangements of I would call of common vents is that the gases are combined before entering the main vent. So this is the combination point number 3. This is a combination point number 1. And this, I would say, even though it is not a combination point number 2 here, I would say this one is number 1. So if the first vent gas stream is coming into here, the second vent gas stream is coming into here, and the third vent gas stream is coming into here. And after the third point, where no more vent gas streams are joining, we call it a common vent. And look how it goes horizontally. That's the biggest distinguisher characteristic of it. And also notice how the vent connectors here are of type C, single wall vent connectors. All right, so always distinguish between the single wall vent connectors and the vent connector manifold when you see them in application. The codebook sometimes refers to the manifold as a manifold, but sometimes it refers to it as combined before entering the codebook. Entering the main vent. Here's where the codebook talks about the manifold, and it says if vent connectors are combined prior to entering the common vent, the maximum common vent capacity listed, and it goes on to explaining what needs to be done. But this is absolutely a manifold, because when it continues and describes the same arrangement, it says the horizontal length of the common vent connector manifold. So it uses the word manifold to describe it. And the good news is that you have all kinds of figures in the codebook at the end of the annex. So for example, if we go to C9, as the clause is referring to, oh look, this is the manifold that we've been talking about. Here are the vent connectors, and this is the vent gas streams combining right here and then entering the manifold. So this is an arrangement called figure C9. And also the good news is that there are C1 through C10 images. So if you go, for example, C8, this is another arrangement. C7 is another arrangement. Other examples are C2. This is another arrangement. So you have C1 through C10 in Annex C of the codebook B149.1 that are images, concepts, abstract concepts of arrangements for the venting systems, different venting systems. In addition to the vent connector manifold, there is also something called the common vent offset. Sometimes you simply cannot go straight up when you're building your common vent, and you will have to yield and change direction and go up in another point. That is what we call a common vent offset. And they look alike. They both look like they are horizontal runs, and I obviously agree with that. They are horizontal runs. However, the manifold is not there because we needed to shift the vent. The manifold is there because when you combine those vent gas streams, we have to combine them in a horizontal run. That's the rule. In a common vent offset, however, what we're doing is we're offsetting the main vent. Okay, so the main vent cannot go up, and this creates a lot of difficulty with recognizing which is which. So my question here would be that if you can pause the video and think about the question I'm going to ask you, what is the easiest way to distinguish between the two? On the left hand, you have the manifold. On the right hand, you have the offset. I'm using single words to call these. And according to what you can see, and you can see differences between the two, what is the easiest way to distinguish between the two? You can pause the video and think about it for a second there. The easiest distinction is that a manifold has one elbow of the main vent or the common vent, and on the other side you have two elbows in the main vent or the common vent when it is an offset. These are the most important points. If on the main vent you have one elbow, such as this one, we call that a manifold. This is your indication that this is a manifold. In real life, it is easier to distinguish because in real life, as you've seen in the image before, you can make sense of the construction and see how the streams are being joined in. But on a two-dimensional drawing, sometimes it is more difficult. So if you see one elbow versus two elbows, you know which is which. And sometimes I'm asked, okay, what about this second elbow here? So if this is the first elbow, what about this second elbow here? Well, that second elbow is not a common vent elbow. It is a vent connector elbow, and that's the main difference among the manifold and the offset. In the next part of the lecture, I'm going to start by asking questions, and then we're going to learn about the vent sizing.